Subsets. A subset is a set of elements that is a part of a larger set. For example, if we have a set A, which is a set of natural numbers from 1 to 10, and if we write this in roster or tabular form, that would be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have a set B, which is the set of natural prime numbers less than 10. In tabular form or roster form, it would be written as 2, 3, 5, and 7. Since 2, 3, 5, and 7 are also all elements of both B and A, like all of B is a part of A, it is a subset. And as a Venn diagram, it looks like a larger circle with the smaller circle inside, and the smaller circle contains the elements in both A and B, and then the remaining elements of A are only in the yellow circle that represents set A. Here is another example. Set C is the set of natural odd numbers less than 10. So in tabular or roster form, it would be written as 1, 3, 5, 7, and 9 inside of the braces or curly brackets. And set B is the same as what we showed in the last example, a set of natural prime numbers less than 10. So 2, 3, 5, and 7. We can notice that not all the elements from B are a part of C, like 2 is not a part of set C. So therefore, B is not a subset of C. Here's another example. Set D is going to be all positive multiples of 6, and set E will be all positive multiples of 3. So is D a subset of E? Explain. And then is E a subset of D? Explain. Well, let's actually investigate this. So first let's write out each of these sets in tabular form. So first let's start with D. D is going to be all positive multiples of 6. So that's going to be 6, 12, 18, 24, 30, and it keeps going. Okay, and now set E are all the positive multiples of 3. So we have 3, 6, 9, 12, 15, 18, and it keeps going. So if we compare the elements of D and E, we can see that, well, D, all of those values, and if I kept going, I would get 24 and 30, they're all within E. So yes, D is a subset of E because all of its elements or all of the elements of D are also in set E. Now let's look at the second question. Is E a subset of D? Explain. Well, 3 is not in set D. 6 is. 9 is not also in set D. 12 is in set D. So you can see set E, there are more elements in E than there are in set D. So therefore the answer to this question is no. Not every element from E appears in set D. And here are the solutions to these two example problems, and they do match the solutions that we found. Since all the elements in D are also elements of E, D is a subset of E. However, not all the elements in E are also found in D. So therefore, E is not a subset of D. Now, the properties of subsets bring up a very interesting question. Can a set be a subset of itself? Let's think for a minute about the definition of subsets. If we have a set T, would every single element of this set T be in T? Well, yes, of course it would. It would have to be. So this allows us to say that set T is a subset of T, or that T is a subset of itself. But is this proper to say? Take a moment and pause this video and think about it, and when you're done, unpause it. It doesn't really seem proper to say that a set is a subset of itself, and this leads us to what are known as proper subsets. A proper subset with just a sideways U notation, or a C with elongated horizontal sections. A proper subset is a set of elements that is a part of a larger set, and at least one extra element exists in the larger set. So in our earlier example, where set A is the set of natural numbers from 1 to 10, and set B is the set of natural prime numbers less than 10, being 2, 3, 5, and 7, all the elements in B are a part of A, and A contains more elements than B does. Therefore, B is a proper subset of A. Now let's try an example with proper subsets. Let's let D be all the positive multiples of 6, and set F be the set 6, 12, 18, 24, and 30. So then, is D a proper subset of F? Explain. So first, let's write out what set D is in tabular form to make it easier for us to analyze it. So set D are all the positive multiples of 6. So we have 6, 12, 18, 24, 30, and so on. And we have set F as 6, 12, 18, 24, and 30. So is D, this one that keeps going, a proper subset of F? The answer here is no, because D keeps going on forever and ever. D is not, first of all, it's not a subset of F, so it can't be a proper subset of F either, because not every element from D appears in F. Now let's reverse this. Is F a proper subset of D? Explain. Well, F starts with 6, 12, 18, 24, and stops at 30. D has all of those same elements, and then it continues, and it'll have 36, 42, 48, and so on. So therefore, yes, F is a proper subset of D, because every element from F appears in D, and set D contains more elements. And here are the solutions to these two example problems, and they do match the solutions that we found.